Hi there, and welcome to the Air Equipment LLC YouTube channel. This is our fifth and final segment of our discussion on the basics of fans and blowers. With fans and blowers, our three primary variables are CFM, static pressure, and horsepower. Our flow, our resistance, and how much energy is needed to make that flow happen. However, when selecting fans, please also keep an eye on RPM and sound. These are two really important variables, and it can be a problem when you don't consider those two items. For example, here is a selection. And whether it's the catalog data or the software selection program, it shows you what size fans can do the performance at a stable spot on the fan curve. But not all selections are the same, and not all selections are good selections. Look at this one here. The first one it shows is a size 60, the 60 SQNB in the square inline fan. And yes, that fan can do the performance of 450 CFM at 0.35 inches of pressure, but it needs to run at 3,700 RPM. And the sound level is 83 decibels, which is very, very, very loud. The next size fan, a size 70, that's down to 2,500 RPM, which is still awfully fast for a small fan. The sound's gone down somewhat, but it's still loud. The selection highlighted in blue, size 80. Now we're down to less than 1,500 RPM. The decibels have gone way down to 56, and it actually uses a much smaller motor. It costs less and uses less energy. So keep an eye on that, because RPM and sound can really cause problems if you don't take care of that, if you don't keep an eye on that when doing your selections. Now these ones here, these are belt drive fans, a small little square inline fan. I would suggest that if we went instead with a direct drive fan, here's a couple of options, a size 90 or a size 100. In both cases, the RPM is really good, horsepower is low, sound is low, and as we discussed in our previous segment, being direct drive, it's less expensive, it's easier to control, and the maintenance is minimal compared to a belt drive fan. So when selecting fans, yes, the flow and the resistance and the horsepower are very important variables, but keep an eye on the sound and the RPM, and whenever possible, especially in smaller applications, less than 1,000 CFM, half inch of pressure or less, almost always a direct drive fan is a better choice. One of the reasons why direct drive fans are becoming the better choice is what's called ECM, electronically commutated motors. The ECM motor is a development, it's been around for a while, but one manufacturer had the patent on it and the price was really steep. But in recent years, the patents run out. A lot of different manufacturers are now in the market and prices have come way down, and it's a much more affordable option, and it really does give you a lot of flexibility and a lot of performance in your commercial air moving products. The EC or PM, sometimes it's called PM, permanent magnet motor, it consists of a motor module. The motor module has a permanent magnet brushless DC rotor and a wound stator, like a typical motor. But what's interesting about the EC motor is that it also has a control module, electronics that are connected right to the motor, and that's really the brains of the product. That control module allows so much flexibility in the speed and changing speeds and controlling this direct drive motor. There are some really good advantages of the EC motor. First, it's inherently more efficient than some of the older technology motors we've been using in the past, like a shaded pole or permanent split capacitor type. That brushless DC permanent magnet simply operates more efficiently. It delivers more horsepower output per amps being drawn in. In other words, you get more bang for your buck. You get more work for the same amount of electricity being drawn off the grid. It's just more efficient. Next, it's programmable. This is a really interesting feature. All the fans that we provide from the Lauren Cook Company come with, they can either be balanced in the field by turning a screw right on the motor, if you just need single CFM, just a straight steady flow. However, you can also bring a low voltage control signal to the motor and ramp the motor up and down as needed. But even beyond that, the motor can be programmed to sense a change in torque. For example, if this EC motor technology is being used with a fan-powered ceiling HEPA filter unit, really nice product that can be used, especially if you want to clean the air in a particular, say, what used to be an office space, but now it's going to be an outpatient surgical center. Instead of having to run all the supply air for the whole building through a HEPA filter bank, which is really expensive, just in that one space, you can put a HEPA sealing module on your supply duct, fan powered, and that will bring in sterilized clean air into that one room. Well, the problem in the past with those fan powered sealing HEPA units was that the fan just ran at a constant speed, and so when your filter was brand new and had the least amount of resistance, you would get more than your desired airflow. And as the filter loaded up and got dirty, you get less and less airflow. You're riding it right back up the fan curve. And then finally, when it was time to change the filter, when it was its dirtiest, you would get less than desired airflow. But using the new EC technology with these fan filter units, the motor can be programmed to sense a change in the torque. It can sense resistance increasing on the fan, and it automatically will increase the RPM, so you get a constant CFM through the filter, even if the filter is anywhere from brand new clean all the way up to dirty in need of being changed. You get that constant CFM that the motor will adjust its speed as needed. So that's a terrific little feature there. And by the way, these fan-powered ceiling HEPA units are provided by Invarco, one of our favorite companies. So the EC fans are programmable, a great feature. And finally, these EC motors that we supply with our fans, you get the full impact of the fan law horsepower savings. Remember we talked about that in a previous episode where with the fan laws, when you reduce the flow, you get an exponential savings on the electric bill because the horsepower requirement drops so drastically. Well, you get that full effect with the EC motor. With old type of technology, the direct drive fans we've seen in the past using a permanent split capacitor motor and on a speed control switch, you didn't get any energy savings because a lot of the voltage was just being converted into heat in that switch. Yes, it was slowing down the fan so you could balance the airflow, but you weren't saving any energy. Now with the ECM, you actually get the full effect of the fan laws. So that's the end of our presentation. Thank you so much for being here with us at the Air Equipment LLC YouTube channel. If you have any questions at all about this topic or any other commercial HVAC air moving topic, feel free to give us a call. We're in East Hartford. The number is 860-290-6969, and look forward to hearing from you. And my name's Bill Dunn. Thanks a lot and have a great day.